Hey YouTubers, welcome back to this session 12 of Java Full Stack Made Easy. Hope in the last session was interesting for you, and in the last session we discussed about the elements of a method. Also, I told you the importance of creating methods with return types and everything. And if you remember, I also told you that in this session we will be discussing about the access specifiers and access modifiers. So one important thing before starting this session is that this complete series is made for those who are hunting for the job or people who wants to brush their skills. Okay, and the main idea, the main motto behind creating this series and me putting up all these efforts is only one, that is to land somebody a job. Okay, so that's my main motive behind these videos. All right, so without wasting much of the time, let's get back to our topics. So in the last session I gave you one assignment, if you remember, that was to count all the small case characters in a given string, and I ask you to guess the return type of the same. So I hope that you have already guessed this return type of this method, that should be an int, and you should write the logic. The logic would be you have to count all those characters that falls in range of what 97 to 122, right? So between that particular range we find out all the small case characters, that is the ASCII value range of small case characters. So if the character is found in that, you just increment the counter count plus plus, and at the end you just return the counter. So that was the logic that will be used to get the answer for this particular question. And also for your practices and everything, what I have done is I have created another repository, a new repository here as assignments. So if you get into that repository assignments, you will find one assignment is already posted for you, that is array assignments. So there will be coding questions into this array assignments with the description and the pseudocode. There will be no actual code given to this, but for reference, like since this is just the initial days of the series, so a pseudocode is given to you. Maybe as the time progresses, the pseudocode will not be given to you. Okay, this pseudocode is to make you understand like what are the steps that you need to follow to solve the below given questions. So if you want to read out these things, so you can just go through this once and you will be able to understand it. So I'll just highlight the first question here. So the first question says find the largest element in an array. So this is the question, and the description about the question is that return the largest number in the array. So consider that it's a numeric array and you have to get the largest element, the max element from that particular array. So hint is given, start by assuming the first element is the biggest, then compare each remaining element with it. If you find a bigger one, then replace that element with it, so update it, right? So a pseudocode is given for it for the same. You can see that initialize max with the first element, then loop through with the array. If current element is greater than the max, then update the max element. That means max will be the current element. Else again you repeat, return back to your loop. Okay, at the end return the maximum value. So this way only the pseudocodes are given to you. You have to frame this into a proper Java code. I hope this concept is now clear to you. The questions are clear. Pseudocode is given, so there are many questions given here. So I encourage you to solve these questions. Okay, nothing happens over a day, definitely takes time. So you have to put your efforts, you have to give it some time, then only you will be able to learn it, and then you will polish your skills. So nobody has become programmer in one single day. So let's get back to the topics that we were discussing, and the assignments are already shared. So you can go to Java Full Stack Made Easy, the GitHub link, which in every video I'll be sharing it in the description. So you'll find that the link of this again in the description. So you can get into the assignments repository, and within that you will find something called as array assignments. So we have already discussed about the arrays, and you should be doing the assignments for arrays now. So then I talked about the access specifier and access modifier. So in today's session we'll be talking about the access specifiers, access modifiers. So whenever I deal with the access specifiers, I also show people about concept of packages. So in this session we will be talking about the access specifiers, access modifiers, and the concept of packages as well. So let me just clean up everything that I have written before, so that it will be easy for us to focus on the current topic. So I'll just remove off all the comments and everything that I've written. Let's talk about the access specifiers in Java. So even in demo 1, I'll just clean up everything that I had called. And in the previous session, I highlighted this part to you, import statement. So today we will learn what exactly that import statement is all about and how do we import things. So access specifiers in Java, what are the access specifiers, and how many access specifiers are there? What is the purpose of using an access specifier in a class? So let's go to our drawing board and understand how many access specifiers are there and how to utilize each one of them, what functionalities they give, how do they behave. So before we understand access specifiers, what we have to understand is we have to understand packages in Java. So just consider that I am creating 2 packages. Now what is a package? A package is a collection of related classes. Okay, so a package is what? Collection of related classes. That means whenever I am creating any software, so a software is what? A software is not just one single program, right? It is a set of programs, correct, written to achieve a common objective. That is how we define a software, right? So a package is a collection of related classes. Whenever you are building a software, you might create some classes that connect to the database. You will create some classes that are related to your business logic. You will create some classes that focus on the UI, right? So there are related classes that will be created. So each related class, like for example, I am creating a software application. I will put all the database related files into a package called as com.mydatabase.database files, something like that. Okay. So whenever next time I want to modify a database file, I will go to that particular folder, that particular package itself, and then modify that particular file. So in general, like if you want to understand packages, it's nothing but what? If I have to tell you in layman's terminology, packages are nothing but folders. Okay. So why do we create folders? See, if I give you some nodes, like if I give you Java nodes, and then I give you C++ nodes, then I give you SQL nodes, I give you Angular nodes. So each of these nodes, what you will do is you'll create a folder and then you will put those nodes into that particular folder itself. So why do you put it into that folder? Because after like say a month or 2 months or 6 months or 1 year, if you want to find out any Java nodes, you can get into the Java directory and find out the nodes there, which will be easier for you to understand, right? Similarly for C++, SQL and Angular. Even in these examples that I'm sharing you here on the Git, I've created subdirectories, right? Day 1, day 10, day 11, 2, 3, 4, likewise. So why did I create it that way? That is because it will be easy for you. Whenever you watch a video, you can particularly go to that particular directory and find out the files into it. Similarly, whenever we are creating a software also, we organize the files into folders. So those folders itself are called as packages in technical term. Okay, so package is nothing but a collection of related classes. So consider that here I am creating 2 packages. Let's call it as pack 1 and pack 2. Okay, the best naming convention for packages is that we have to give 3-part name. We will understand that 3-part name and all that in our later session, but as for now, just consider that there are 2 packages which I am creating. One is pack 1 and there is another one that is called as pack 2. So what I'm going to do is I will be creating some classes in this. So I'll create a class 1 in package 1. I'll create class 2 in package 2 and class 1, 2 and 3 in package 1. And I will create a class 4 in package 2, class 5 also in package 2. So we know that Java, since it is object oriented programming, we know that there is reusability of the code available through inheritance, right? So parent child classes can exist. Now consider that C1 is a parent of C3, okay, and C5 is also child of C1. So C1 is a parent of C5 and C3. The difference is that C3 is there in the same package, whereas C5 is there in some other package. So one important point again you can note by this example is that in Java it is possible that a parent class can exist in a different package and a child class can exist in a different package. It is not mandatory for a child class to be present in the same package itself. So you can create child classes in any package, parent class in any package. But whenever you are creating packages, ensure that you put related classes into it. Okay. So now, what are the access specifiers available in Java? So access specifiers available in Java are four. One is public, another one is private, one is default, and then protected. So these are the access specifiers that are available in Java. Now what is the work of a access specifier? What it does? Okay, an access specifier actually defines the access level of a method or a variable or a class. So access specifiers can be applied to a class, a variable, or a method, and it defines the access level. That means if suppose there is a method here in this class C1, suppose I have declared that method as X, okay, and if this method X is public, so it means that X can be accessible anywhere. So this method has to be given some access specifiers. So based on that access specifier itself, the method will be visible to the other classes. So you can put it at these four access levels. So in a class, if you do not define anything, like in my previous examples, if you have seen, whenever I was creating classes, I generally create something like this, right? Void display. So if I don't give any access specifier here, by default, Java gives the access specifier as default. So this is the default access specifier. The name also is known as the default itself. If you don't give anything, by default, it is default access specifier. So likewise, what I can do is I can give four access specifiers here. I can give public, I can give it as private, I can give it as protected. Okay, so these are all the allowed access specifier, and based on this access specifier itself, the method will be available into other classes. For example, if I give it as private, private methods will not be available into other classes. So what I'm going to do is, let's create a simple class here. Let's say class demo class or something. Okay, so in a demo class, what I'm doing is I'm creating a method private void display, and it is private as for now. Then let's create a main method and then try to create an object of this demo class and call that particular method here. Demo d equals to new demo class, and then I'm trying to call a d dot display method. So if I try to do that d dot display, you can notice that I'm getting an error because the method is created as private. Private means it is available only within the class where it is declared. It will not be visible outside. So display method from type demo class is not visible. If suppose I make it public, then it will be visible. Okay, so this access specifier actually tells where all the method is accessible. That's why it is called as access specifier. So tells it is used to mark the access level of a method or a variable or a class, right? If class is not written with anything, it is default by default, and if a class is written as public, it is a public class. So classes can be at only two levels, that is either default or public. You cannot have a private class. Okay, classes cannot be private unless they are inner class. So that is again a very tricky question. Can a class be declared as private? So the answer for that is yes, classes can be declared as private only if the class is inner class. If it is an outer class, no, classes can be at only two levels, that is default and public. One more important point that we have to add here is that two public classes cannot be there in a same file. You can see that I have created two public classes. I'm getting an error here. That is because public class name and the file name should be same. That's another rule. So whatever class is declared as public, that class name and the file name should match. That's why we cannot create two public classes, because we cannot give two names to the same file. So two public classes cannot be there. Another recommendation is that whichever class you create as public, ensure you create a main method inside that particular class itself. So while you are watching this particular video, you have to also make these notes. That is, class cannot be declared as private or protected until and unless it is a inner class. Then two public classes cannot be there in a same file. So these things which I am telling you, you have to note these things down, or you watch the videos again and again, you will memorize these things. And one important point again to add is that when you can increase or decrease the pace of these videos to suit to your requirement. Okay, well, let's go back to the access specifier. So we basically have four type of access specifiers available into Java. So let us understand each one of them. If suppose anything like any method is declared as public in C1 here. So that means it is accessible to everyone. So public is for everyone. Let's write those access specifiers here and then also write where all it will be visible. So public means it is visible everywhere. Public, visible everywhere. Now the next access specifier, that is private. So any method that is declared as private is visible only within the class where it is declared, be it a method or a variable. Classes cannot be declared as private, right? So any method or a variable declared as private is accessible only within the class where it's declared, that is private. Then the default one. Now default means it is package friendly, means if anything is declared as default in this class C1, so C2 and C3 can access it because it is a package member. So only package members can see it. C5 is a child of C1, still C5 will not be able to access the function return into C1 because it is declared as default. So default is visible only within the package. C5 is not part of this package, that's why anything declared as default here will not be visible to C5. So which means default visible to only package members. Okay, and I will add one important point here. Child outside the package, even the child outside the package cannot access it. Okay, so moving to the last one, you just ignore these spelling mistakes, at times I do that. Then protected. Now this one is quite interesting. Protected is what? If anything is declared as protected in class C1, so first, as per this normal object oriented rule, is that all the child class will be able to access the protected members. So that statement remains true in Java also. All the child classes will be able to access protected members. But in Java there is one addition. What is the addition? Even the package members, even though they are not child, can still access the protected properties or protected functions. That means if suppose X is declared as protected here, C5, C3 can access it, even C2 can access it, but because C2 is a part of the same package. So protected members are visible within the package and the child. Okay, even if the child is outside. Child is outside the package. Okay, so irrespective whether the child is a part of the same package or it is outside the package, protected members will be visible for sure. So this is the description and the working of access specifiers. Now let us put this access specifiers to the classes and understand whether they truly behave that way or not. Okay, so again here you will also learn how to create packages and everything. So I will keep these things that I have written here as it is. So I'll just copy this and create new classes for you to understand the things. Okay, so let me cut this from here. I'll close this calculator, also the demo one. So both I have closed. Now I will create new classes as I have created here. So there is C1, C2, C3, C4 and C5. So 5 classes I have to create in 2 packages, pack 1 and pack 2. So first I will create classes for pack 1. Okay, so let's go ahead and create the classes within the package. Now you can notice that when I expand this, there is no package, there is no folder here. Default package is what it has created. So I'll now create a new class, and you notice that there is one option there, that is create a new package. So we can create a package and then create a class, or what we can do is we can create a class, with the class itself we can create a package. So I'll create a pack 1 here. Okay, I'll call it as pack1. I can write it as pack1 also, but it is not good practice in packages to include numbers, and even capital case characters should not be included into the packages. That is the good practice. If you see any of the package in Java, you will never see numbers being added into the packages, and you will never see capital case characters being added into the package. Class names can be capital, but packages will not be capital. It will all be in small cases. That is the best practice given in Java. So I have something called as pack1. So here I will create a class with the name C1 itself. Okay, so let's have this class. So I've created one class called as C1. Same package. Now you notice that previously I right clicked on the source and created a class, so I had to give a package name. Now if I right click on the package itself and then create a class, you will notice that the package name is already given to me, right? So that is the easier practice. Now I will create a C2, done, and then I will create a C3 here in the same package. Click on the package, right click, new class, and then create a C3. So I created class 1, class 2, class 3 as per the diagram, right? But one thing I did not create is that C3 is a child of C1. So I have to do that. So in this example, you will also see how do we create parent and child classes. So it is very simple. If we want this C3 to be a child of C1, then we can just say extends C1. That's it. So by doing that, we will make this C3 as a child of C1. Now package 1 is completed. Let's talk about this package 2. Pack 2. C4 and C5 has to be created. Once again, what I have to do is right click on the source, new class. Now instead of pack 1, call it as pack 2. And this is our class 4, C4. Let's create that. And you can notice it here, there are two packages created. Pack 1 and pack 2. C4 is a part of pack 2 and all these other are pack 1. Now one more class I'll create, that is C5. So let's create C5 in pack 2. You can notice that that's the same package. Done. And now I will extend this class also with C1. Now you notice that in the previous example, when I was extending C3 with C1, there was no problem. So it got extended. Now when I'm trying to extend C5 with C1, it tells me I cannot understand C1. Why is that? That is because there is no class called as C1 in this package. So you notice it here. If I put my cursor on this, it says C1 cannot be resolved to a type. That means I don't understand what is C1. So if I write something like pack1.c1, so it means that now it is understanding C1. So it is taking C1 from this pack C1. Okay, so this is what we have to do. But what can happen is there can be multiple instances where I want to make use of this C1, right? So whenever I want to make use of this C1 multiple times, at that time, instead of writing these names again and again and again, what I can do is I can simply say import this, import pack1 dot C1. So this way we can import it, or we can also import a star. Star indicates all the classes. But the best practice is always give the class that you want to import. Else what happens is, if you give star, in this case if you give star, C1, C2, C3 all will be imported into your class. So it will just be a waste of memory. Why do you want to load all the classes when you are not using it, right? So the best practice is always import the class that you want to use. Do not use star. If suppose this package contains some 100 classes and you are using some 97, 96 classes out of it, at that time you can write pack1 dot star instead of writing 96 lines explicitly. If it contains 1000 and you are using only 96 out of it, write 96 lines rather than writing a star there, because you don't want all the classes to be loaded unnecessarily. Hope you have now understood two very important parts about the packages. One is, if any class has to be a part of some package, you write a package and the package name there. We did not write any package name. For all these classes also, we did not write any line like this, right? It has automatically taken this package and the package name. This is because when we were doing this, right click, new class, here itself we are giving the package name. Suppose if I give the package name as testing here, automatically this class, let's call it as my class. So my class, or let's call it as my main class, So main class will automatically be a part of the package testing. Package testing will be added on top of it. So you can see that package testing is already added on top of this main class. Okay, that way we can make the classes as a package member, or we can create a class and put it into any package by mentioning this. So let me do that as well. So let's create a dummy demo class. Let's create a class, and if I don't mention any package here and then I call it as demo and then finish it, so it's not a part of any package now. If I write something like package and then write the package name my dot new dot pack, so if I write this at this time, sorry, new pack should be there, dot abc or anything, any package name you write, so it tells me that there is no package, there is no folder with this name. So what I can do is I can move this into this package. Automatically a package at the left hand side will be created. If I do that, you can see that, or I can remove the declaration that is written. So I want to create a package and put this class into that particular package. So I can simply click on this. You can notice that there is one package created which is my dot new pack dot abc. Okay, which basically means that there is a folder src. Within the src folder there is a my folder. Within my folder there is a new pack folder, and within that there is a abc folder, and within that you have this class. So you can view it physically if you open your workspace. Okay, let's see it in the system explorer. So you can see that I have Java full stack made easy source, and within the source the packages that I created, pack 1, pack 2 and testing, all of them are just created as pack 1, pack 2 and testing. You can see that, sorry, pack 1 just simple pack 1, and for pack 2 also just the pack 2. But for this class that I have created, even for testing it is just pack testing. But for this demo class, you notice my dot new pack dot abc. So whatever dots I am using here, it is a new folder created for that. So you can see that there's a my folder, there's a new pack folder, there's a abc folder, and within that we have the demo.java file. So that way the whatever dots you separate, for each dot a separate folder will be created for you. So that's why I told you a package is nothing but a folder. So like pack 1 is a folder here. Within this folder I have 3 files, c1.java, c2 and c3.java. Similarly pack 2 has 2 files, and the testing also has 1 main, and these 2 classes are in the default package. So this way we can create packages, organize the classes into the packages. So I hope now you have understood 2 important things about the packages. One is how do we create the packages, how do we put a class inside a package. Second is how do we import the classes from other packages. So here I am importing a C1 from a pack 1 because C5 is a part of pack 2. And another point to be noted, very important point, is that there can be 2 import statements. That is, in suppose if I want to use testing here, then it is fine. I can go for testing dot any class there. So what is the class that I have created? My main. I can import that. There can be 2 import statements, but a class, one class cannot be put into multiple packages. So if I write a package statement once again, you notice that I will start getting an error. Package, so I will make it pack 3, or let's say pack 1 itself, which is already there with us. So you can see that package statement, syntax error on the token, package import expected, right? So there can be only one package statement, there can be multiple import statements. I hope the concept is clear to you. So what I will do first is I will put all these files into the repository. After that we will check all the excess specifiers that are given here. So one by one I will put everything starting from C1. So if you copy this and you don't find a package same as this, you can just click on the error and then move the class to that particular package. A package will automatically be created for you. So I'll go here. So Java full stack made easy. This is our session 12, so I'll call it as day 12. It's not required that you have to do it on 12th day, 13th day, or the sessions that I'm writing. So in a day I'm releasing 1 session. You can cover up 2 or 3 sessions also. But please ensure that you don't just watch the video. Along the videos you practice the things. Okay, so let's call it as day 12 / this is demo 1. Let's call it as packages. So I have this pack1 C1, and as I told you, whenever I'm using multiple classes, so I'll be separating those classes with this line. So I have C1 in pack1, C2 in pack1 again, and C3 also in pack1. C3 is a child of C1. So that's why an extends keyword is written there. You can see that. So in this example, you also understood how do we create parent and child classes. Then I have created a new package, pack2. Okay, and two classes inside that pack2, C4 and C5. C5 is also a child of C1. Looks good. And lastly, I have a testing package which contains the main class, my main class. So let's copy it and get this. So I'll commit. Everything looks good now. So let me go back, and now let's talk about the concept of this access specifiers and test each of the access specifiers into different classes. So first I will check public. I'll create something as public in C1 and then I will test it. So let's go ahead, let's go to C1. Let's get into the full screen mode, and here I will create a public int x is equal to 10, and also I will create public void display, and this display just does what? System.out.println. It does x. Let's save it, and now I will go to my main class. Okay, or first I will try to test this display method inside this C2. So I'll go to C2 and create a main method here in the C2, and I will try to create an instance of C1. C is equal to new, let's call it as C1 itself is equal to new C1, and then I will try to call the C1 dot display function. So let's save it and run it, and now you can notice that I am able to call the C1 display method, right? So let's just write it as C1 display method here, system.out.println C1 class display method. Okay, let's save it and go here. You can see that C1 class display method is being called. I will also try to do a system.out.println, and I'll say a C1.x, which is a variable, right? And the value of that variable is 10. So I'm just calling the variable x from that particular class. So I'm able to call it. Or looks good. Everything looks fine. So I'll put this code as well into the repository where C2 is calling the C1 properties. So create a new file, demo2, C2 calling C1 with public. Okay, this is C1 where I've created the public variables, and then the C2 class with public. We know that public means everywhere, so in any class I write this, it will all be valid. So even if I go to some other package, like for example, if I write this main method inside the class with maybe let's say C4 also, it is still fine. So I can just create an instance of C1 and I have to perform an import statement because that's a part of a different package. So I have to use an import. I just pasted it automatically. My ID understood that this comes from C1. So looks good. Let's save it and run this piece of code and see. So everything looks good because it is public. So it should be accessible in C4 as well. So I'll copy this, and then again I'll put one more demo. So demo 3 C4 calling C1 with public. Okay, so I'll put that code here. Done. Now what I will do is I'll go ahead and use the other access specifier, that is private. So what if I make the properties or methods of C1 as private, and then I will try to call it in the other two classes, that is C2 and C4. Let's test that. So we know that if it is public, then it will be accessible only within the class that we have declared. Okay, I think that part is gone. Let me check, where did I write that? Maybe in calculator or something. Yeah, here I had written it. anyways. So I'll close this demo 1 and calculator, not required as for now. So let's go back to what we were analyzing. I'll write it here once again for your reference: public visible to everyone. So here we have tested that public is visible to everyone. Second statement said that private visible within the class where it was declared, right? So within the class where it's declared. So let's go ahead, let's save this and test it now. So I'll mark this variable as private. Now you notice what I'm doing. I'm marking the variable as private, but method is still public. Now when I go to C2, you notice that I'm not able to access this variable here because it is private. X is private, cannot access it here. Okay, but now I save this program and run it. So when I run it, you notice that C1 class display method is called and the value 10 is given. So which means that display method is being called, and display is calling what? Display is calling X. So indirectly you can call a private method, sorry, private variable, but you cannot directly call it. That's because this method is public. It can be accessed outside the class, right? Outside the package as well. But this variable cannot be directly accessed. So that is why on this line we are getting an error saying that private variable cannot be accessed here. Method display is being called. Display method is a part of this class itself. So the display method can access this private variable. I hope even this concept is pretty much clear to you. So I'll put these two again into the repository. So because I have made that private, again here also in some other package I'll not be able to access it because it is private. Okay, so let me copy this again, C1 and C2. So this is demo 4, C1 with private variable in called in C4. So that's the name I'll give. So this is the class C1 where I've made the variable X as private, and method is not private, method is public itself. So public should be accessible here in C2, but if I try to access the variable, this gives us an error. You can try uncommenting this line and then you can check that error. Nice. So two access specifiers we got to know, that is public, which is visible everywhere. Then we got to know about private, which is visible only within the class where it is declared. So these are the two easiest one. Now let's talk about the other one, that is the default. So if any variable is declared as default, it will be visible within the package. Now what I will do is I'll go to C2 and uncomment this line. So when I uncomment this line, so here it will be accessible. Visible because X is default now and C2 and C1 are in same package. So because they are in the same package, it will be accessible. So if I run this C2, there is no problem here. Now what I will do is I will try to go to C4 and then try to uncomment this and check it here. So you can notice that it is not visible here. Okay, error, X is default, cannot access it here because C4 is not the same package member. So you'll get an error there. All right. So let me save this and I'll give you both. So this is our C1 where I mark this as default. So you don't need to write a default here. If you write default, it will give you an error. So you don't write default there. If you don't write anything, then it is default, because default again is a keyword in Java, right? So in switch case we have used that keyword. So you should not be using a default there. Now demo 5. Demo 5, the default access specifier. So this is my class C1 where X is declared as default. C2 in same package. Okay. So since C2 is there in the same package, there will be no problem. And then C4 in some other package. So obviously that should give us an error, and it is giving us an error. Great. So let's just commit this as well, and let's go ahead and see the last one, right, which is protected. I'll go here and change this to protected. I'll save it. So obviously if it is protected, it should be visible into C2, it should be visible into C3 as well, right? So irrespective whether it is child or not, if it is accessible to non-child, then for child obviously it will be accessible. For C4 it will not be accessible because it's neither a part of the same package. Error X is protected here, cannot access it here because C4 is not in the same package. C4 is not the same package member and not even the child. Okay, let's try and write this into C5. Now let's write a main method directly in C5. Now you see it should be accessible in C5, right? If it is declared as protected, C1, anything declared as protected, it should be visible to C2 and C3, same package members. C5 as it is a child, although it is a part of some other package, but it is a child, right? So let's go ahead and check in C5. So here is C5. I write the main method, and I don't need to access or create the object of parent class. There's no need to write C1. I can directly create the object of C5 because child inherits parent's properties, right? Child is inheriting the property of parent. So display method will be an inherited method, and also X will be a inherited variable. So you don't need to create the object of parent in child class because child is an extension of parent. Protected can access here because it's a child. Protected can be accessed because C5 is the child of C1. So I hope now everything that I have given to you is clear, be it public, private, protected or default. So protected is not visible here, so let me give you everything. C1. Now the protected access specifier, let's add that demo 6. Class C1 first, where X is declared as protected. Then I'll give you class C2, same package member. You can notice that you can see that it's a part of the same package. So I think I don't need to write it here, but just for your reference, I'll write same package member, not a child. Okay, it's just a same package member, but not a child. So even though it is not a child, you can still access it. Next is C4. I am trying to access. C4 cannot access it. C4 not the child, not the package member either. Okay, so I've written that. Lastly, C5 not the package member but a child. So C5 should be able to access it. Fine. So I hope all of these access specifiers that we have discussed here are clear to you. Public, private, default and protected. Now if I ask you to organize this access specifiers with the highest access level comes first, means whichever access specifier gives the highest access, you should rank it first. So which one comes first? Public, because that is visible everywhere. Then next highest accessible access specifier is protected because it is visible to child classes plus the package members. The third highest is the default one, and the last one is private. So there is a reason why I asked you to organize this in this way. You are ranking the access specifiers like 1, 2, 3 and 4. These are the ranks that we are providing to the access specifiers. In future this rank will be used. So that is why I asked you to organize this. Now I believe that the concept of access specifiers is pretty much clear to you. In our next sessions we will be talking about the access modifier. So about a method, we have discussed about the access specifiers that we give. We already talked about the return type that we give. Then we talked about the identifiers of a method, and then we have also talked about the arguments of a method. Only part that is left is this method being static, which is a access modifier. We have already discussed about one type of access modifier that can be given to a method, that is static. And this note you have to once again I'm reminding you, class can either be public or class can be default. Classes cannot be private, classes cannot be protected until and unless it is a inner class. So this can be 100% your either a interview question or a OCJP question. You can see it here, I can create a class within the class. So this is an inner class. If I give a class as private here, it is not valid. You see, you start getting an error there, right? So illegal modifier. Classes can be only at 2 levels. Okay, I'll write it here, or I will better write it to a plain class. You should not be confused with the child class. So I will better write it with a simple plain class, that is C1. So I'll try and write here, class can only be at 2 levels, public or default. Okay, and classes cannot be private. If I try and do this private here, not visible. Okay, it's not allowed in fact. So even if I write protected, not allowed. I may write it as default or I may write it as public. If I don't write anything, it is default. If I write it as public, it is public. Okay, public or default, unless it is inner class. Okay, what is an inner class? A class within a class is an inner class. So here I am creating a class itself. You can see class. Now I can mark this class as private. It is completely valid, no errors at all. Warning is there because we are not using this inner class. We created it, we are not using it. And now class can also be protected because it's an inner class. It is valid. We can access this protected class also. And classes cannot be something like static. You cannot give the access modifier to the class. But if it is an inner class, we can mark it as static also. So inner classes are acting like a method only. That's why all these things are valid there. So these can be your questions that will be generally asked in the interviews. So I hope the concept that I have covered in today's session is completely clear to you. Once again, I am reminding you about the assignments that I have already shared with you. So please go through with the assignments here in the main repository. You will find out the repository called as assignments. Within that, as for now, I have added the assignments for arrays. In future sessions, I'll be adding more assignments related to maybe packaging, access specifiers, or string classes, or looping and all that. Okay, so with this array assignments, looping is already included. Okay, and even the normal operators like greater than, less than, and all that is already included into these assignments. I hope you are enjoying the sessions, and if you are following this this series, then do comment that you are following the series and encourage me to make more such content. Thank you for your cooperation. See you in the next video.